Hi everyone, it's Ian here from Crack Maths, and welcome to this past paper walkthrough for this functional skill level 2 style paper in the style of Edexcel. And this is paper 1, version 1, section A. If you want to get this paper to download to have a go at and work along with me, you can simply go to crackmaths.co.uk, and if you go to the resources section, which you can find here, go to past papers, and you'll see here it is, sample paper 1, version 1, and this is in the style of Edexcel. Now, if you work through this and you just want to watch this video now, watch through with me and see how it's all done, and then you want to have a go at a slightly different paper, what I've done is, because I've made these past papers, I have also done a version 2 and a version 3 of these papers where they're the identical paper, but I've just changed the numbers. So if you want to do that, that is something that would be worthwhile doing. If you wanted to stretch yourself but not too far, and you wanted to make sure that you'd really grasped what you've learned in this past paper walkthrough, that would be an excellent thing to do. Okay, right, so let's have a look at this paper. Now, first of all, what I've got here is, you can see on the screen, it's got functional skills level 2, and this is just the cover paper, okay? So obviously here you don't need to know about this, but we've got the place to put our name, so I'll put my name here. And then you can put your surname there as well. And then here we go. There's just the kind of instructions that they have. I'm going to move on from this because this bit isn't particularly exciting, because I know that you're here for the questions. So let's move on and have a look at the first question. So question 1 says, Susan drives to work. At the end of her street are a set of traffic lights. The traffic lights are either on green, amber or red. Last week when she approached them, she found that half of the time they were on green and 2/5 of the time they were on red. What fraction of the time were the traffic lights on amber? Okay, right. So there's only 3 things that can be happening in this situation, which are the traffic lights are on green, they're on amber, and they're on red. So what we know is that 100% of the time they are on one of these 3 things. Okay, so this is actually a probability question, really. So we're looking at for the probability that they are going to be on amber. So we can either do this question using fractions all the way throughout, or what we could do is we could convert these things into percentages and then convert that back into a fraction at the end. I'm actually first of all going to go through this percentage method because this is the non-calculator paper, and this method's actually a little bit simpler if you can't remember how to add fractions. Not that you can't, but just in case you can't. So what I'm going to do is I'm going to have a look at these, and I'm going to think about these fractions in terms of percentages. So if I look at this half, I know that a half is 50%, okay? That's something that you probably know as well. It's one of those fractions, percentages, decimals that we kind of know anyway. We would actually also know that this, if it was a decimal, would be 0.5. Okay, the next thing that we have here is this 2/5. Now, you might not know what 2/5 is as a percentage, so what I'm going to do is I'm quickly going to use fractions to work it out. So remember, a percentage is a fraction out of 100. So I've got 2/5 here. Now I know that that's going to equal 4 out of 10 because I've multiplied both of them by 2. So remember, fractions are equivalent if we multiply the bottoms and tops by the same thing. So now that means that this is also going to be equal to 40 out of 100. Okay, because we've times that by 10 and we've times that by 10. So here we go, we can see that 2/5 equals 40 out of 100, which means it equals 40%. Okay, so half of the time, 50%, they were green. 40% of the time, they were red. Perfect. So now what we can see is we know that they're either green, amber, or red. We know that 50% of the time they're green. We know that 40% of the time they are red. So that means if we do 40 add 50, that equals 90%. So basically, we've already got 90% of the time covered. So we just need to do 100% minus 90%, and that equals 10%. So we know that 10% of the time the lights are on amber, but they've asked for what fraction of the time. So what we need to do is we need to remember that 10% means 10 out of 100. So I'm going to write that as 10 out of 100, and that equals 1 out of 10. So there we go. The answer to that first question was 1 out of 10. Okay, right. Now, I'm also now going to quickly go through the way that you would do it with adding fractions. So let's now have a look at this question if we just forget about the percentages. And I'm going to think about this, and I'm going to remember that if there's three things that are happening, they have to add up to a complete fraction, okay? So they have to make sure that the fraction is full. So I know already we've got half of the time they're green, and I know that 2/5 of the time they are red. So there we go. So we know that the red and green together are going to make up a half plus 2/5. So hopefully you remember how to add fractions. If you don't, remember the key thing is to remember that they need to have the same bottom number. So they need to have the same denominator. Right, and the way that we can do that is to think about the first number that we can think of, we can have half of, and we can also have fifths of. Okay? So, this number here happens to be 10, because I know that I can have half of 10, and I can have fifths of 10. So, I know that 1/2 equals 5 out of 10, and that's because I've times the top and the bottom by 5. Okay, remember, with equivalent fractions, as long as we multiply the tops and the bottoms by the same thing, then that's fine. So I know that that half here becomes 5 out of 10. I also know that 2/5 becomes 4 out of 10 because I've times the top by 2 and I've times the bottom by 2. So here we go. We've got 5 over 10 plus 4 out of 10. Okay, so here we go. Remember, this half is the same as 5 over 10, and 2/5 is the same as 4 over 10. If you type these into your calculator, they would give you the same decimal answer. So now we've done this, we can add these together. Remember, when we're adding fractions together, the denominator stays the same. So now we know we've got 5/10 add 4/10. So 5/10 add 4/10 makes 9/10. Okay, so here we go. So that's our answer to this first part. So we know that half of the time plus 2/5 of the time equals 9/10 of the time. So now remember, we were talking about certainty. So that means that if it's certain that the traffic lights are green, amber, or red, that has to be 10/10 of the time. Okay? So if we know that we've got 9/10 of the time and we need 10/10 of the time, we can do 10/10, take away 9/10, and that's going to equal 1/10. Okay? Which is actually what we got in the last question as well. So we know that our answer to this question, where it says what fraction of the time were the traffic lights on amber, is 1/10. Okay, let's now have a look at question 2. Right, so here we go, we've got question 2, and this is work out 2.3 multiplied by 7.9. Right, so we've gone through several methods of how to do this. What I'm actually going to do for this is I'm going to think about these numbers as 23 times 79. Okay? Right, now, because I'm using 23 and 79, I've got to remember that my answer is going to be times 10 times 10 bigger, because 2.3 times 10 gives me 23, and 7.9 times 10 gives me 79. So I need to make sure that I divide my answer by 10 twice. So must divide answer by 10 twice. Right, now what I'm going to do is I'm going to use a grid method here. I think it's called the lattice method for long multiplication. So here we go. I've got a box like this, and I'm going to put 23 at the top here. and I'm going to put 79 at the side here. Now what I've got to do with this method is I've got to divide each of these boxes in two. Okay, and now I can start to work out these questions. So first of all, I've got 3 times 7. So 3 times 7 is 21. Now I've got 3 times 9. 3 times 9 is 27. Now I have 2 times 7, which is 14. And next I have 2 times 9, which is going to be 18. Okay, now remember with these, what I do is I add down each of these columns. So I'm going to do 7 here. Now I'm going to do 1, add 2, add 8, which makes 11. Okay, remember, I'm just going to put that here to remember to add that in with these ones. So for this column, I've got 2, add 4, add 1, add 1. So 2 add 4 is 6. 1 add 1 is 2. 6 add 2 is 8. So that column makes 8. And this last one here, I've just got 1 by itself. So I can see here that 23 times 79 is going to be 1817. Now, I must divide the answer by 10 twice. So I'm going to put my decimal point at the end here. And then once will go to here. And then twice will go to here. So the answer for this question is going to be 18.17. Okay, now in maths, in these papers, we often get questions like this, where it says, use estimation to check your working. Right, and so what that means here is, it means that we have to round our numbers that we were going to multiply together to make the calculation simple. So I'm going to say that 2.3 becomes 2. I'm going to say that 7.9 becomes 8. And then I'm going to think about how 2 times 8 equals 16. So if 2 times 8 equals 16, 16 is very close to 18.17. So that is a good estimation check. So I'm happy that this is correct. Now, the thing that they're really testing with this was that we put our decimal places back in the right place. Because if we hadn't put them in the right place, our options were 1.817 or 181.7. And we can see that neither of these are very close to 16. Now let's have a go at the next question. So here we go. Here's a question where it's got a two-way table. Ooh, these numbers aren't the nicest for a non-calculator paper, but I have put this in because I have seen this kind of thing in the past. So here it says, Rizwan's company has 2 offices, one in Birmingham and one in London. Rizwan is told to review the way employees travel to work. Rizwan presents his findings in a two-way table. So here we go. We've got commuting method at the top and we've got city at the side. So I can see on the top here that it's got a total of 100. And I can see that these two things are 20 and 35. So I know that 20 add 35 equals 55. Now, I also know, luckily, that 100 take away 55 equals 45. So I can put here that 45 people travel by car. Now, this calculation is quite straightforward as well. We know that in total there was 200 people. We know that 100 people came from Birmingham. So that must mean that there's 100 people in London. So I can put my 100 there as well. Right, now let's have a look at this bus column. So the bus column is actually quite straightforward. We know that this 20, that 20 plus something here is going to equal 24. Okay, so I know that 20 add 4 equals 24, so I'm going to put a 4 there. And now what I've got here, I'm going to do this column as well, because it's only 2 things. So I know that the people that travelled by car, okay, there was 45 and there was 8. So 45 add 8 is 53. So I know that altogether there was 53 people there. Right, now I can pick which one of these to do. I'm going to do the the London row here, okay, just because the numbers are smaller. So I've got 8 people came by car, 4 people came by bus, the rest of them took train, and the total is 100. So 8 plus 4 is 12, and I know that 12 add 88 makes 100. So therefore that must be 100 there. And now what I've got here, I've got 35 and 88. So that's a little bit of a harder one. Okay, I might actually just scroll down and do this one with the column method. Okay, so if I've got here 88 plus 35, you might be able to do this in your head. So 8 plus 5 is 13. So put a 3 there and a 1 there. 8 add 3 is 12. 8 add 3 is 11. 11 add 1 is 12. So here we go. So that should be 1, 2, 3. Now, I just want to double check that I have got this table correct. So I'm just going to add that last row together. So 53, add 24, add 1, 2, 3. Oh, let's get that right. 1, 2, 3. Okay, so 3 add 4 add 3 makes 10. 5 add 2 is 9, add 1 is 10. Okay, and then 1 add 1 is 200. Okay, so I'm confident there that I've got those numbers correct. Right, let's now have a look at the second part of this question. Okay, I'm going to keep that there because I think we're going to need this. So here we go. So Rizwan is told to look at the people who travel to the office by train and bus. Okay, what is the probability that these people work at the London office? Right, so I'm going to get my highlighter here because we've been told a subset. And here is our subset here. Okay, we've been told that we want to look at the people that travelled by train and bus. So my first question is, how many people is that? Right, so we can see that that is going to be 24 people plus the 123 people. That equals 147. So if we're looking at the people that travelled out of bus and train, okay, we're looking at 147 people. So now we're looking for the people that live in London. So let's have a look back at this table. So we want the people that work in the London office. So here we go. So it's these people that work in the London office. So that is going to be 4 people and 88 people. So I know that 4 add 88 equals 92. So the probability that of the people that travel by train and bus, that they work in the London office, that probability is going to be 92 out of 147. Okay, I did not make that box big enough for the answer. Okay, right, let's now have a look at the next paper. Right, so here we go. We have got question 4 here. So this is a very classic type of question, and it says here, Jay needs to buy grass seed for his lawn. Here is a scale drawing of the lawn. So the scale is 1 centimetre, represents 2 metres. A box of grass seed covers 10 metres squared. Jay thinks he'll need 6 boxes. Is Jay correct? You must show you're working. There's several things to think about here. This is a compound area question, but very luckily it's a very nice compound area question because they're only wanting us to know the area of rectangles. So I can see here, I'm going to divide it like this, okay, and to see that I've got 2 rectangles. First things first, I need to know what the area of a rectangle is. So area of a rectangle is going to be length times width, okay? And now what we need to do is, if we've got the area of the rectangle is length times width, we, first of all, whenever we get a scale like this and its area, if you don't change things straight away, it gets messy. So I'm going to use this scale to convert all these lines. So if I know that 1 centimetre equals 2 metres, okay, I can see that 3 centimetres will be, I've times this by 3. I'm going to times this by 3 as well. So that'll be 6 metres, okay. So, and that's quite easy to see. So essentially we're just doubling all of these sides. So that would be 6 metres. This would become 10 metres. This would be 4 metres. And this would be 6 metres. Now we need to work out this length here. Okay, so if I know that from here to here, is 10 meters, and from here to here is 6 meters. I can do 10 take away 6, and that will equal 4. So I know that that's 4 meters. Now, if we know that this rectangle here has a length of 6 and a width of 4, we know that the area of this is 4 times 6. 4 times 6 is 24 meters squared. And now here I can see, oh wait, this one is also 4 by 6, which is very convenient. So this one is 6 times 4, which is also 24 meters squared. So I can see that the total area of this shape is going to be these areas added together. So I'm going to do 24, add 24, and that equals 48 meters squared. Okay. A box of grass seed will cover 10 meters squared. Jay thinks he'll need 6 boxes. Is he correct? So, if one box equals 10, we've got 6 boxes. Okay, so to go from 1 box to 6 boxes, we're timesing by 6. That will equal 60. Okay, 6 boxes will do it, but I think I can see here that it's actually overkill. I don't think we need 6 boxes, because I think if we had 1 box is 10, if I got 5 boxes by timesing this by 5, and I times that by 5, 5 boxes would equal 50. And 50 is more than 48, so he is wrong. So what I'm going to do is I'm going to conclude here that no needs 5. Okay, that's a bit ambiguous, so what I'm going to do is I'm just going to write my answer here as well. No, J only needs 5 boxes as the area is only 48 meters square. Right, okay. That is that past paper done. So remember, if you want to have a go at this, you can print it off at crackmaths.co.uk. If you want to have a go at a similar one, there's version 2 and version 3 available for you. I hope that was useful, and hopefully see you in part B. Okay, bye.